My name's Sarah Tessendorf, and I got my undergraduate degree in meteorology at the University of Nebraska-Lincoln. I came here for graduate school, so I got my master's degree here in 2003, and now I'm working on my PhD. Well, I'm interested in severe storm research, and I am studying severe storms that occurred in the high plains in Colorado and Kansas particularly. And we're using radar data. In fact, we're using high-tech, innovative radar data from the CSU Chill radar. It's Doppler and Polarimetric radar data. And we're using that data to study the kinematics and microphysics of these severe storms that occurred on the high plains of Colorado and Kansas. In particular, we're looking at these storms to determine why they produce positive cloud-to-ground lightning. There tends to be a climatological maxima in positive cloud-to-ground lightning in the storms that occur in Colorado and Kansas. So there was a field experiment in the summer of 2000 called STEPS that we went out there with 3 radars and we studied these storms, took data from these storms, and I'm working on the analysis from that data set. Recently we traveled to Mexico. We took radar data of some monsoonal type storms off the coast of Mexico for the NAME Field project. Other travel that I do is mostly to go to conferences. I travel to conferences at least once, maybe twice a year. I just got back from one in Boston, so that's most of the travel I do right now. In the future, we have a few more field experiments on the planning boards, one in Houston and one in Africa. Dr. Rutledge definitely lets us work at our own pace and do a lot of our independent research ourselves. We have a lot of regular group meetings and we have individual meetings with him to discuss our research, but he's definitely not breathing down our back to make sure that we're doing it the way he wants. He gives us a lot of flexibility to take our own ideas and run with them and discuss them with him. One exciting thing that's going to happen in hopefully about the next 5 years is the operational Weather Service radars are going to be upgraded to have polarimetric capabilities. And one thing that's going to need to happen is the Weather Service forecasters are going to need to be trained on how to use polarimetric radar. And I would surely love to be involved in creating some training modules and going out and training the forecasters based on my experience and education in polarimetric radar. One of the reasons why I think that our department is so highly ranked is because we have a lot of faculty members that study a broad range of research topics. And so from that, they can bring in a lot of students into this one department and work on a lot of different areas, and there can be interaction between those research groups as well. In addition, our faculty members are very good at obtaining research grants, and so we have a lot of funding to help fund graduate students' research activities and their tuition, pay their tuition and so forth. And I think that's a highly attractive offer for graduate students to know that they have secure funding for their graduate program. In addition, we have top-ranking facilities. The CSU Chill radar facility is one of them. We're building a brand new atmospheric chemistry building, and we're going to be hiring a new atmospheric chemistry professor. We just hired an oceanography professor, and so we're really expanding as well. But we've got great programs in climate, we've got great programs in remote sensing and radiation, in atmospheric chemistry, in dynamics. I mean, it's really across the board. If you like atmospheric science, you can find something that you could enjoy here. And because of that, we have these many faculty members that have all these different specialties. So in our coursework, we get exposure to a lot of different areas of atmospheric science. And I think the department really cherishes that breadth of education that you can receive here.